Hello friends, myself R.D. Mahajan presenting my video on Fourier Series revision part 2. Let us solve the problem. Find Fourier series for f of x is equal to x minus x square in the interval minus 1 less than x less than 1. This problem we can solve by two different ways. The first one is function is neither even nor odd in the interval minus 1 to 1. Therefore, we can apply a full range Fourier series. Therefore, here full range Fourier series is given by f of x is equal to a0 by 2 summation of an cos n pi x by l n changes from 1 to infinity and summation of bn sin n pi x by l n changes from 1 to infinity. We call this as equation 1. First step, we try to get the value of L, where value of C is minus 1, the value of C plus 2L is 1. Substituting the value of C as minus 1, we get 2L is equal to minus 1. If we transfer to right hand side, it becomes plus 1. 1 plus 1 we get 2, and therefore L is equals to 1. Where A0 is given by 1 by L integration from C to C plus 2L f of x dx, and therefore 1 by 1, value of C is minus 1, C plus 2L is 1, function is x minus x square. Its integration with respect to x, we get integrating each term with respect to x, integration of x is x square by 2, integration of x cube is x square is x cube by 3, and limits from minus 1 to plus 1. Subtracting the upper limit, for upper limit we get 1 by 2 minus 1 by 3, and minus for lower limit minus 1, minus 1 square is 1, and minus 1 cube is minus 1 by 3, and therefore 1 by 2 minus 1 by 2 get cancelled. We get minus 1 by 3 and again minus 1 by 3. That sum is minus 2 by 3. This is the value of A0. For getting A0 correct, you will get 1 mark. If the problem is asked for 6 marks. Then we require to find an, and an is given by, formula is 1 by L integration from C to C plus 2L f of x multiplied by cos n pi x by L and its integration with respect to x. Substituting the values, we get L is 1, therefore 1 by 1, C is minus 1, C plus 2L is 1, fx is x minus x square, and into cos of n pi x by L, L is 1, therefore it becomes cos of n pi x, and then its integration with respect to x. Here it is a product of two terms of x. First one is algebraic, second one is trigonometric. Therefore this must be the first and this one as second, and integrating it by generalized part, we get first term x minus x square, integration of cos is sin n pi x divided by n pi, then minus differentiation of this with respect to x 1 and minus 2x. Integration of sine next is minus cos divided by n square pi square, then plus differentiation of this with respect to x, its derivative is minus 2. Its next integration is sine with this minus sign, therefore minus sine of n pi x by n cube pi cube. Next derivative is 0 as we have constant here, and therefore we stop here, and the limits are from minus 1 to plus 1. And therefore when we substitute the values, we get sin n pi and cos n pi. Therefore value of sin n pi is 0, cos n pi is minus 1 raised to n. For lower limit, we have sine of minus n pi, means once again we get minus sin n pi, and the value of sin n pi is 0, and cos of n pi with minus sin s, means we require these two values for upper and lower limit. We get 1 minus 1, we get 0. 0 into this term, we get that first one is 0. Minus 1 minus 2, minus sign, and again minus. 3 times minus, we get minus. 1 minus 2 is 1, therefore with minus sign. And cos of n pi, and the value of cos n pi is minus 1 raised to n divided by n square pi square. Minus minus become plus. Sin n pi, value of sin n pi is 0. Then for lower limit, minus 1 minus minus 1 square. Therefore minus 1 minus minus 1 square. It is minus 1 plus 1, 0. Therefore this term once again becomes 0. Cos of minus theta is cos theta minus this minus plus, and 1 minus 2 times minus 1, we get 3. Therefore it is with minus minus plus 3 times. Cos of n pi, value of cos n pi is minus 1 raised to n divided by n square pi square. Then substituting value of x as minus 1, sine of minus n pi, and value of sin n pi is 0. Therefore this becomes 0 with minus sign. And therefore minus 1 times, and this is minus 3 times. Addition is minus 4 times minus 1 raised to n divided by n square pi square. Value of an. If we perform this correctly, if all steps are correct, then you will get 2 marks for finding an. Then bn is obtained by, formula is 1 by L integration from c to c plus 2L f of x multiplied by sin n pi x by L. Substituting the values, we get 1 by 1 c minus 1, c plus 2L is 1, therefore it is integration from minus 1 to 1. Fx is x minus x square, and into sin of n pi x by 1, therefore it is sin of n pi x only. Its integration with respect to x, again a product of two terms, therefore integrating it by generalized part. X minus x square is an algebraic term, therefore we consider it as first, and sin is trigonometric, therefore that term as second term, and therefore first term x minus x square, integration of sine minus cos n pi x by n pi, then minus differentiation of this is 1 minus 2x. Next, integration of cos sine with this minus sign, therefore minus sine n pi x by n square pi square, then plus differentiation of this term with respect to x is minus 2. Next, integration of sine minus and this minus, it becomes plus cos of n pi x by n cube pi cube, and next term becomes 0 as this one is a constant term, and then limits are from minus 1 to plus 1. Substituting the values, 1 minus 1 we get 0, minus minus, and 1 minus 2 again minus, 3 times minus sine of n pi, the value of sine n pi is 0, therefore that second term is also 0. The third term minus 2 times cos of n pi minus 1 raised to n by n cube pi cube, minus next minus 1 minus 1 minus minus 1 square, minus 1 square is, therefore that term becomes minus 1 minus minus 1 square, which 1 minus 1 minus 1 minus 2 and again minus, therefore it becomes 2 times cos of n pi minus 1 raised to n upon n pi, sin n pi 0, therefore this becomes 0, cos n pi, cos of minus n pi is cos minus theta is cos theta, and therefore it is cos of n pi, and value of cos n pi is minus 1 raised to n, therefore it is minus 2 times minus 1 raised to n upon n cube pi cube, and if you simplify it, this is with minus sign and minus minus plus cancel each other, and therefore the value of Bn is minus 2 times minus 1 raised to n divided by n pi. That is the value of Bn. 2 marks for this if all steps are correct. Then after finding the values of a0, an, bn, substituting it here in equation 1, we get the required Fourier. Therefore, substituting the values, we get Fourier series for function fx x minus x square is equal to a0 by 2, a0 is minus 2 by 3 divided by 2, summation of an cos n pi x by l, an is minus 4 times minus 1 raised to n divided by n square pi square into cos of n pi x, n changes from 1 to infinity, summation of bn, the value of bn is minus 2 times minus 1 raised to n by n pi into sin n pi x. This is the required Fourier series, and for getting this last step correct, you will get 1 mark, total 6 marks. That is this scheme of marking. This is the first way to obtain the required Fourier series by applying full range Fourier series concept. The same problem we can solve by another method. Given fx is x minus x square, it is sum of the two functions, that is first one is suppose f1x and minus second one is f2 of x. It is neither even nor odd, in the interval minus 1 to 1. But if we consider individual function f1 of x as x, and in the interval minus 1 to plus 1, and as it is minus L to L type, we can check its type. Therefore, replacing x by minus x, we get f1 of minus x as minus x, and that is f1 of x is an odd function. Is an odd function, and as it is an odd function, value of a0 is 0, an is also 0, and only we require to find bn, and bn for this function x, 2 by L integration from 0 to L f of x sin n pi x by L, and its integration with respect to x. Substituting the value of L, here minus 1 to 1, minus L to L, we have L is equals to 1, and therefore 2 by 1 integration from 0 to 1 fx is x sine of n pi x. Integrating it by generalized part, as here it is product of two terms. The first one is algebraic, second one is trigonometric. Therefore 2 times first term x, integration of sine is minus cos n pi x divided by n pi, then minus derivative of x 1, next integration of cos is sine with this minus sign, therefore minus sine n pi x by n square pi square, next derivative 0 we stop here, and limits from 0 to 1. When we substitute upper limit, we have the term cos n pi and sin n pi. Once again, the value of cos n pi is minus 1 raised to n, and sin n pi as 0, and therefore we get 2 times x is 1, therefore with minus sign, cos of n pi minus 1 raised to n divided by n pi, minus minus plus, the value of sin n pi is 0, that term becomes 0, then minus, for lower limit it is 0, and sin 0 is 0, and therefore if you simplify this, we get that value as minus 2 times minus 1 raised to n by n pi as value of bn. Therefore here I have obtained the values of a0, an and bn for the first function x, which one, or it is an odd function. Therefore second function is x square. Check whether it is even or odd. Replacing x by minus x, we get f2 of minus x as minus x bracket square, we get x square, means same function, and as we get same function, that function is an even function, and for even function we require to find the value of a0, 2 by L integration from 0 to L f of x dx. Therefore, performing the integration, 2 by L, L is 1, lower limit 0, upper limit 1, fx is x square, and then its integration with respect to x, we get that value as 2 times integration of x square is x cube by 3, limit from 0 to 1, therefore 2 by 3, upper limit 1, lower limit 0, therefore the value is 2 by 3. Then an is given by 2 by L integration from 0 to L f of x multiplied by cos n pi x by L and its integration with respect to x. Substituting values 2 by L, L is 1, integration from 0 to 1, fx is x square cos of n pi x. Integrating it by generalized part, as here it is product of two terms. First term is x square, second one is cos. Integration of cos sin n pi x by n pi, then minus derivative of x square is 2x, integration of sin minus cos n pi x by n square pi square, then plus derivative of 2x is 2. Next integration is sin with this minus sign, therefore minus sin n pi x by n cube pi cube. Next one is 0. We stop here and limits are from 0 to 1. Substituting the values, for upper limit it becomes sin n pi, and sin n pi is 0, the first term is 0, minus minus plus, 2 into 1 we get 2. Cos of n pi, value of cos to n pi is minus 1 raised to n upon n square pi square, and sin n pi is 0, therefore minus 0. For lower limit, x is 0 0, x is 0 0, and again sin 0 is 0, therefore all the three terms are 0, and therefore if we simplify it, we get that value as 4 minus 1 raised to n divided by n square pi square. This is the value of an, and bn is 0. As it is an even function, and therefore taking the sum of two a0s to an and to bn, we get, therefore final values of a0, an, bn are a0 0 minus 2 by 3, we get minus 2 by 3, an of first minus an of second, 0 minus 4 times minus 1 raised to n divided by n square pi square, and therefore we get that value as minus 4 times minus 1 raised to n upon n square pi square, and bn as bn value for the first one is minus 2 times minus 1 raised to n upon n pi, and minus bn of second, that one is 0, and therefore we get that value as minus 2 times minus 1 raised to n upon n pi. And then substituting these three values here in this Fourier series result, we get fx x minus x square, a0 is minus 2 by 3 divided by 2, summation from 1 to infinity, the value of an minus 4 times minus 1 raised to n divided by n square pi square into cos of n pi x and plus summation from 1 to infinity, the value of bn minus 2 times minus 1 raised to n divided by n pi into sin of n pi x. Means we get the same answer as I had discussed in the first technique. Therefore, in exam you can use any technique, whatever you feel easy one, use it. In my next video, I will discuss another problem on Fourier series. If you like my video, please share it as well as subscribe to my channel, and to receive the notification for my new videos, you have to press the bell icon. Thank you. Thanks for watching.